All right, pre-algebra students, today we are going to write linear equations from tables and graphs. So we should be able to use the information in tables and graphs to write linear equations. First, we're going to start by reviewing slope-intercept form, which is how we write linear equations. We will talk about how to interpret the information in tables and graphs, and then we will use those in the context of real-world situations. So make sure that you are following along with your guided notes, and let's get started. So, slope-intercept form. This is the way that we've been writing linear equations since we learned how. We need two pieces of information in order to write the equation of a linear function. First, we need the slope, or the variable m. We need the y-intercept, or b. And when we find m and we find b, once we have these two values, we will write equations in the form y equals mx plus b. That's y equals m times x plus b. You may have seen multiple formats of this equation. So for example, y equals 2x minus 6. The slope would be 2, and the y-intercept, since this is minus 6, the y-intercept would be negative 6. Here's another quick example. If we have the equation y equals 1/2 x, that means the slope, or m, the number that's being multiplied by x, is 1/2, and the y-intercept, the number that's being added or subtracted at the end of the equation, well, I don't see anything, so the y-intercept for this equation would be 0. So that's just a quick review. Now let's talk about how this plays into tables and graphs. For a table of values, we can find the slope by calculating the change in y, so one y value minus another, divided by the change in x. And you've seen me write it this way before. Delta y over delta x just means change in y divided by change in x. And in the table, we look for the y-intercept as the value of y, where the x value is equal to 0. 0, or just the O. So let's take a look at this table and let's try to write an equation from it. I want to find the change in y over change in x, and that's how I'm going to find my slope. So slope is change in y over change in x. And if let's look at the change in y as I move down from 4 to 6. So in order to jump from 4 to 6, I actually have to increase by 2. So my change in y is positive 2. To make that same change in x, moving from the first row of the graph from the table to the second row of the table, I'm moving from negative 1 to 0. Now that's increasing. That number is getting larger, and to get from negative 1 to 0, I have to add 1. So my change in x for the table would be positive 1. 2 divided by 1 is just 2. So my slope is 2. The y-intercept. The y-intercept is the x value, or sorry, it's the y value when x equals 0. So let's try to find a place where x is 0 in this table. I can see I've got a coordinate right here. So when x is 0, y is 6. So that means in this specific table, the y-intercept is 6. So now we know the slope, we know the y-intercept. Our equation, when we put this together, would be y equals 2x plus 6. There you go. And so let's try this out with graphs. Graphs are a little bit different of a process. From a graph, we can find the slope by setting up a ratio of rise over run. Basically, it's the same thing as the table. Change in y is the rise, change in x is the run. Basically, change up and down divided by change left to right. And then for your graph, we look for the y-intercept as a point where the graph crosses the y-axis. We should be pretty familiar with this by now. So let's just take a look at a graph and a line here. So for slope, remember we're looking at rise over run between any 2 points on the graph. So I'm going to choose 2 points. Here's one, here's another. 2 points that are on the line. So I'm going to find the rise over run. My rise between these points, I'm going to move down 1. If I'm decreasing by 1, that is a -1 rise. And my run, moving left to right, my change left to right between the points, I'm moving to the right 1, 2, 3. When I move to the right on the graph, that means I have a positive change. And this change is 1, 2, 3, change of +3. And so when I put that together, my rise over run is -1 over +3. That's just -1/3. My slope is -1/3. For the y-intercept, I'm finding the place where the line crosses the y-axis. And I already identified that coordinate. It's right here. The coordinate is at 0, 3. So you'll notice x equals 0 at this specific point. So when x is 0, y is 3, my y-intercept is +3. Now let's put that together. I have my slope, I have my y-intercept. My equation of this line is y equals -1/3 x plus 3. So let's try this process with some real-world situations. Here's our first problem. Luke's family goes to the movies and purchases a large popcorn. They are debating whether or not to purchase any drinks. The table shows how much they'll spend based on the number of drinks they decide to purchase. So it says when the number of drinks is 0, the total cost is $6.25. If the number of drinks is 1, the cost is 10, and it increases from there. So let's find the slope. So I'm going to look at the change in the total cost per number of drinks. And basically we can assign variables to this. Cost would be y, number of drinks would be x. To find the slope, we're going to subtract our y values and divide it by subtracting our x values. So we would have, for the slope, 10 minus 625, just subtracting. 10 minus 625 divided by 1 minus 0. So 10 minus 625 would be 3.75, and 1 minus 0 is 1. The slope would be 375. The y-intercept is the value where x equals 0 in the table. So I'm seeing this point right here. When x is 0, y is 625. So that means the y-intercept, the starting value, is 625. That means without purchasing any drinks at all, we're paying 625. And so when we write the equation, we're going to put this information together. Slope is m, y-intercept is b. The equation would be y equals 375x plus 625. The slope in this situation represents the cost per drink. So when we look at the slope, that means we are paying $3.75 per drink. The y-intercept in this situation represents the starting value. And when I look at the starting value, it's the cost when we don't buy any drinks. So $6.25 when 0 drinks are purchased. And there we go. Let's try one more. Betty's Bakery uses a chocolate chip cookie recipe that calls for a certain ratio of brown sugar to butter as shown in the graph. So this time we're interpreting a graph in the information here. Let's find the slope first. We already have 2 points labeled for us. I'm going to find the rise over run. My rise is my change in y, run is change in x. So the rise, it looks like my y value for the lower point is 3, for the upper point it's 6. So basically 6 minus 3 would be positive 3. My run, my change left to right between the points would be from the x value 4 to the x value 8. So from 4 to 8, 1, 2, 3, 4. Positive 4 would be my run. So if I put this together, my rise is 3, run is 4, my slope is 3/4. We're going to keep the fraction. The y-intercept is the point where the line crosses the y-axis. And where I look where the line crosses, and it looks like it crosses right at the origin, at 0, 0. So when x is 0, y is also 0. The y-intercept is 0 here. So let's write an equation with this information. Remember that we are writing in the format y equals mx plus b. So the equation that would fit that format would be y equals 3/4 x. We could write plus 0, but we don't really have to here. So the slope in this situation represents the ratio of brown sugar to butter is 3/4. 3 cups brown sugar to 4 cups butter is what that's saying. The y-intercept in this situation is 0, which basically says 0 cups brown sugar for every 0 cups of butter. And I know that doesn't really make sense in this situation, but for recipes, it's a pretty proportional relationship. We're saying that if, we're not using any cups of brown sugar at all, we're also using 0 cups of butter. For additional practice with interpreting these real-world situations, try out problems 3 and 4. So that is it. Make sure that you're trying out the additional practice problems and check your answers with mine. Ask for support if you need it, and thank you so much for watching. Have a great day.